There is one special redox reaction called disproportionation. Disproportionation means there is only one reactant. It could be a molecule, it could be an atom or ion that goes at the same time through oxidation and reduction. So it's both reducing agent and oxidizing agent. And I'm going to show you three examples. Example one, we have CuCl, two of them, becoming CuCl2 plus Cu. Now, if you look at this reactant, first I go after chlorine in it. Chloride is -1. Cu has to be +1. And if you go on the other side, chlorine is still -1 because now you can go by group 17. Chlorine is located in that. Chlorine is not changing its oxidation state. It goes from -1 to -1. So we ignore that element in CuCl. If you look at Cu, we decided chlorine is -1, Cu is the metal, it better be +1. On the other side, this Cu in CuCl2 is +2. So you go from +1 to +2, that's increased, therefore it's oxidation. Now look at the elemental Cu on the product, it's 0. It's not combined with anything else. So then we compare and go from +1 to 0. In this case, copper is going through reduction. So it's both oxidized and reduced at the same time. Therefore, CuCl has gone through disproportionation redox. It's both an oxidizing agent and reducing agent. The second example, I'm going to look at reaction of OF2 becoming half O2 and F2. Now you have to remember one rule was fluorine. Fluorine is always -1, doesn't have a luxury of changing oxidation state. So fluorine is -1. That means oxygen +2 because you have 2 fluoride. Now if you look at oxygen on the product, it's free, so it's 0. When you go from +2 to 0, that's reduction in the value and it's reduction half reaction. Now look at fluorine that we decided is -1 here. But on the product, you're free, so that's 0, and that's oxidation. So OF2, this molecule has gone both through reduction and oxidation. Therefore, it's disproportionation redox, and it's both reducing agent and oxidizing agent. Finally, we look at the last example. I have 2KClO3 becoming 2KCl plus O2. First, I look at potassium, group 1 plus 1, potassium group 1 plus 1. There is no change, so we ignore potassium. Then let's go after chlorine. What is oxidation number of chlorine? I'm working out here for those of us who are a little bit questioning this. What is oxidation number of chlorine in KClO3? Potassium is +1, oxygen is -2. Let's just do algebra. +1 for potassium, plus chlorine that I don't know what it is, -6 because I have 3 times -2 should equal 0. It's a compound. +1 minus a 6 is -5. So chlorine -5 is 0, so this chlorine has to be +5. So it's +5. On the other side, potassium is +1, chlorine has to be -1, group 17. You go from +1 to -1. That is a reduction, therefore this is reduction half. If we look at the oxygen of KClO3, it goes from -2 to free oxygen, which is 0. That is an increase, therefore it's oxidation. So KClO3 is both oxidant and reductant, oxidizing agent and reducing agent, or we could say KClO3 has gone through disproportionation redox.